For 40 years, scientists have flocked to the KITP to discover and explore the frontiers of physics. They do that by interacting, by coming together, by arguing at the blackboards, drinking coffee, and those interactions they have for these long periods really lead to new fields of research. And those new fields are being defined by the individuals through their collaborations, through those intellectual partnerships and friendships they've forged during their time at KITP. All of that fully entangles the physics community and the outcomes of the Institute, and really has allowed us over the 40-year period to be not only working with all of the physics community, but most importantly, define with them what the frontiers of physics truly are.
Okay, I'm Eva Silverstein from Stanford, and I want to thank the organizers for this wonderful meeting. It's fantastic to be discussing such confusing issues. It's really...
Well, I do remember my first visit, which was a certain program that was focused on the so-called ADS-CFT correspondence. And at the beginning of the program, nobody believed it. It was considered a crazy idea by many people. All of the supposed flaws in the idea were dealt with by Juan Maldacena, who was here, explaining and defending the idea.
So it was this time where I had proposed this relationship between quantum mechanics and gravity. Yeah, it was a kind of duality that you could view the same system either from the quantum mechanical point of view or from the gravity point of view. Some people had some objections, some technical objections, or ways in which the argument I had originally given could fail, but some of them started working on it, and they found more evidence for this relationship.
And by the end, everybody was working on it. And we actually wrote the second or third paper on the subject.
If you look at what the Institute is today, it's roughly the same style and form. We've kept most of the elements of the original proposal. We've, of course, broadened our scale tremendously in terms of the number of people impacted because the demand is there.
Theorists are very gregarious and like to talk to each other and bounce ideas and collaborate. That was the original idea. So it's unusual in the sense that, most institutes or centers at other universities try to construct, they have a special role in creating their own scientific environment. The ideas, the participation, the organization largely comes from the whole world. So it's continually changing. We are able to respond quickly to developments in science, to bring the people together at the right time, and that can have enormous consequences.
But we do see quite often that when a program begins, there are certain questions the program wants to address. When they leave, those questions are actually very different.
What's wonderful is bringing people who were working on the basic subject from all over the world and bringing them together into some kind of choreographed crescendo. And so it was like, almost like an orchestra leading a set of theoretical ideas. It's that kind of social interaction where you're talking about high-level thoughts, but you're doing it in a deep person-to-person interaction that is what I'd say it's what makes KITP really precious.
On day one of the program, in the sort of meet and greet, I was standing next to Rob Myers. And I said, so what are you working on? What are you interested in? And he told me the question, and it happened to be just something that I'd been thinking about. And I said, well, actually, I know how to do that. And he said, okay, let's work it out. And then boom, we had this great collaboration. We wrote one of my best cited papers, which basically involved an extension of the idea of black hole entropy. Jacob Bekenstein had realized that the surface area of the horizon of a black hole is a measure of the entropy of the black hole. And that's actually a result that comes out of Einstein's general relativity theory. But we don't believe that Einstein's theory is exact by itself. It should have corrections to it. It should extend somehow to take into account these corrections. And what we were working on was how does it take them into account? And we found a beautiful way to extend it.
We really work to create that dialogue by social events, by asking each program to talk to the other program specifically. And that dialogue can often lead to a realization that maybe some physical insight or some mathematical technique developed by one physics community is actually very relevant to the other. And so by always having two things happening simultaneously, we actually enable this, still within physics, but in some sense really cross-disciplinary dialogue that can really lead to new insights.
Richard Neher, who was a postdoc here a few years back, and we worked together. It's a project that you don't really expect as a part of physics, but it turns out that the ideas of statistical physics are quite helpful in thinking about evolution of viruses.
Ever since I came here, I've continued to collaborate with Boris Shraiman. So we've used these insights from these rather abstract models to develop algorithms that allow us to predict which influenza strain is likely to dominate in a future season. And that in turn has implications for the composition of our seasonal influenza vaccine, because this flu shot needs to be reconfigured, readapted every year to match the circulating viruses. It was sort of at these conferences where sort of different people from different fields came together, and we sort of realized that yes, these rather abstract ideas might have pretty direct real-world correspondence in these pathogens and virus populations.
We've been able, thankfully, to have 40 years of a very rich history and continued support. And the reason for that is sustained leadership.
KITP has had a series of excellent directors. You need somebody at the helm to guide it, and it's had the resources to run programs that are very topical. There hasn't been anything that I know of in the world besides KITP that could plan with that kind of a time horizon, bring people from all over the world at the right time to focus on a topic.
The science we do here is basic science. And basic science is driven by curiosity. It's not in response to specific societal demands or needs. But indirectly, it produces all the new ideas that answer those needs. So the way I look at knowledge is that, we're always moving out, understanding more, but the more we understand, the more we realize we don't understand, the more questions there are. Just ignorance seems to grow as fast as knowledge.
The future of KITP is permanently entangled with the future of physics. The frontiers of physics will always be explored right here.